put head blocks, flywheels, cranks, and anything that's rusty, anything that's gonna go over to the block aisle, crank aisle to get bore, honed, grinded, polished. Doesn't matter, we put it in here. For instance, if you wanted to take a look over here, we start with something that's really rusty, get it all washed in our hot tanks, dry it, mag it, that's all good. We put it in here. What happens is we put it in, the carriage spins, and there's blades down there that fling the steel shot up, and this is your finished product from the wheel grader.
What I got here is our line hose. So this is how we refinish out our housing bores for our mains. So the reason why this is important is because it'll set up our oil clearances for when we install the crankshaft. So the big part of this is making sure that these are all true to each other and square, as well as the right size. So this is basically how I get this set up, and I'll reset and I'll put my main caps on, and then I'll be able to open it up back to what factory size was. This is our boring barn. So this is our new CNC machine. This is one of our newer ones, our newer additions to the family over here. This machine's really cool because besides for the initial setup, I can click go and walk away from this machine, and it'll run on its own. So it'll do all of its, it'll find its own bores, it'll find the center lines, and it'll run and cut on its own. So I'm able to start this machine, walk away, and go do something else. It also cuts a lot more precise, and it will zero things, and basically I'll have the ability to blueprint blocks if I have to. So it's a huge improvement to what we were doing before, where stuff was on a floating head and locked in. So this is definitely the way. So this machine is our diamond-headed SV10 hone. So this is a Sun-In hone. One of the huge benefits to this machine is that we have diamond hone heads. So the diamonds are going to cut a lot better, a lot straighter, and have a little bit less heat dissipation, or dissipates back into the block and everything. Everything we can do to try and make the cylinders as straight, true, and correct as possible. So what I'll do when I hone out a cylinder is I'll measure the piston, and then I'll set my piston to wall clearance for every cylinder to exactly what that piston wants. So, and some of the benefits of this machine is the machine itself will find and correct any tight spots in the cylinder board. So, I have an example, a demo here. So, as you can see, it's tight here at the bottom, and what it'll do is it'll automatically dwell at the bottom and hone out the bottom to make it a little bit bigger to catch it up so it's even with the rest of the cylinder. So, that's one of the huge benefits to having a newer machine like this is. And then that, along with the diamonds, makes for like a really, really nice cylinder finish. And what we've recently been doing is also getting into measuring our crosshatch angle and our RA finishes on our cylinder bores. So modern day piston rings have been leaning more and more towards going with deeper valleys in the cylinder. So we've been getting into that, spending some R&D on that, getting those numbers correct, and that's really let us lock in on a lot of high performance motors have gotten a lot better, as well as our consistency with grocery getters and things like that. These motors have a lot higher chances of living and living for longer once we get them out the door. So this is our torque plate. So we have torque plates for a bunch of different applications. This one is our AMC torque plate, and we also have extra drilled bolt holes here for in case we add extra bolts. So unlike high cylinder pressure motors, we'll add an extra bolt onto the cylinder head. But what this will do is it'll simulate the torque of a cylinder head being on there. So when your piston and everything is assembled, it'll distort the cylinder the same. What this allows us to do is get cylinders a lot closer bored to the correct bore size without any distortions or anything that are going to make tight spots or even loose spots. So it improves our piston ring seal, and it improves just longevity and performance of these motors.
For this particular head, we're installing guide liners. So they're bronze liners, and what they do is they pick up the gap from the wear from previous use. Over time, the valve will ride the guide, it'll wear the guide, it'll wear the valve. That right here is actually in the process. Some of the guides have already been done, and they've been put in, they've been manicured, groomed. This head is still in the process. I did one earlier to show how they get cut off. They get broached to size, they get honed, and then, like for example, this is what it actually looks like when it comes out of the box. This is what we use to this thing right here. We'll put it in a drill and it'll give it a nice chamfer on the edge. This machine actually will reface your seats to make it concentric with the valve itself. So if we did, I'm not going to actually cut it. And it's a variable speed, so we can reduce the speed to remove chatter, to groom it, and then we can increase the speed to get a very fine finish on it.
I'm Adam. I handle the crankshafts here. Most of the time when stuff comes in, it's got some wear on it, scoring, scratches, whatever it may be. So common practice is to resurface, resize the crank to fit an undersized bearing. So we do that all in-house, and my sizes are based on usually on the connecting rod and the block as far as the line hole and rod sizes. Really allows us to pinpoint the size we're going for, and it's nice to be able to do that in-house. We got to adjust bearing clearances, things like that. We have the capability to do that all in-house. So what we'll do is we'll set the crank up on the grinder here. I've got an assortment of wheels we'll dress depending on the radius and type of crank and everything like that. And you basically get it set up and precision grind down to the 10,000th of an inch. Exactly what we need for the size on a crankshaft to get you the right clearance and a nice, smooth, consistent finish for your engine.
I'm the engine assembler at Don's Machine Shop, and here to show you one of our start pieces. This will be an aluminum AMC 360, a NASCAR style block that we have for a customer that we're building right now, using 4-inch mains, and also running a Chevy rod journal crank with a 3 4/4 stroke. With that, we are using Oliver connecting rods with diamond pistons to put that all together for at least the bottom end. For this NASCAR block, it had a very large cam tunnel bore. We're still learning and researching how and what they did, and we couldn't really find a positive fix to that. So we had to do some building in R&D of our own. So for that, being the customer already ordered a camshaft that was the AMC size, we made individual sleeves to put the stock cam bearing in, so we can still retain all those specs and spaces to use all that stuff that the customers also already bought. The heads are aluminum AMC heads to work with this. Notable, they got the lower head bolt boss hole to be able to secure and seal the gasket. Also on the block, we had to do a little bit of machining on the top end of bush lifters. The ones that were in it were just a little bit too much play that we liked, so we had to remove, install, bore, and hone those to fit an AMC sized Mopar lifter. We are also going to be building it with the top end of a Whipple supercharger. So on top of all this goodness of just the block alone, we're going to be putting a supercharger on it too. It's a very neat build, very unique. We get quite a few stuff like this through here. But on AMC engines, most of the critical parts is the front cover, oil pump gears, making sure you take your time, making sure the surfaces are stoned, they're smooth, they're flat, so that way when you measure your gear protrusion, you can put the correct gasket thickness in and get your clearances correct. That can cause a lot of harebrained oiling problems. Next to inspecting the camshaft for oiling up to the camshaft gear, making sure that those are all in line and that passage will deliver oil up through the cam snout and oil the distributor gear and cam gear. Typical run for a build, start to finish, roughly a month and a half. Depends on part availability. We all know of recent times that has been very turbulent. We haven't had the best luck of getting parts consistently to be able to build on time, but typically it's a month and a half, give and take on what we also got coming in for in-work. So, but once it really gets into the room, I would say the assembly room, it would only take about a week to typically put an engine or less together. Most of these engines I've worked on and put together quite often, so I've gotten very familiar with it. But there are times where I need to stop and look up information to make sure that, yes, on the AMC engine, I did check the oil pump gear housing and make sure that that was all clearance correctly and assembled